Hello everyone. As many of you are aware, I've been sort of on a hiatus, although I've actually been working on a CNC machine. I based it off some Thingiverse files I found, and today I'll be talking about the build process. The base of the machine was made using 20 by 20 aluminum extrusions. I used a set of calipers to determine how long the screws for the 3D printed part should be. The tolerances on the 3D printed parts were a little too tight, probably because of filament shrinkage, so I had to use some sandpaper and a blower to remedy this. After the 3D printed parts were sanded, I used a vise to help me put in the linear bearings. The screws had arrived, so I put a T-nut under the depression of the aluminum extrusion and tightened. When the part was in place, I put a linear rail in to see if it was aligned. I then stole the Arduino from my EDM project and put a CNC shield as well as the stepper motor drivers in order to control the machine. I apologize in advance for the dark footage, but basically the brass nuts were secured using some M3 screws. The person who designed the Z carriage made it really hard to put in the screws. It took a lot of finesse, but eventually I got the screws in. The lead screw was now threaded and it was time to put in the X-axis stepper motor. Now rejoice at the linear motion of the X-axis. I decided to buy a small Tupperware container in order to enclose the CNC shield and Arduino. Here's some footage of me putting in the ball bearing and the lead screw for the X-axis. I used the manual feature in CNC.js just to test if the machine was working. The wires were a mess, so I bought these cheap Velcro cable ties in order to manage them. I should also mention that I used these T-brackets in order to provide a base for the CNC. While the stepper motors were moving, the number of steps they performed were not calibrated. In order to calibrate the machine, I used a 2 cm by 2 cm square design that I made in Adobe Illustrator and imported it into a CAM software. The original Z-axis model was missing from the Thingiverse page, so I had to design my own. I went through a long, arduous process and many iterations before I settled on a final design. The first one came out very warped because the filament required high temperatures in order to print. The second one had less warpage, but it also presented problems in the hole placement and also these walls for securing the spindle. They were a little too thin, which made it weak. I was only aware of this problem after printing this one, and so the third iteration did not fix this, but the hole placement was correct. The problem with this one was for some odd reason, the Z-axis is a bit off-center, so this is, I made it center, but I was not aware of that offset, so it came out wrong. The fourth iteration was the correct one, and I had to offset it a bit to the left, and also I fixed the wall issue, too. After getting a successful print, I meshed the brass nut of the Z-axis with the lead screw and put in the linear rails. Feel free to skip this part if you already know how to do this. Using the calibration G-code I made, I was able to calibrate the machine. You basically take the current number of steps and multiply it by the expected length. And you divide all of that by the actual length. And you should get the correct number of steps. If you end up increasing the number of steps your stepper motor does, make sure you adjust your feeds and speeds accordingly. I increased mine, and I almost burnt the wood because my CNC machine was moving a little too fast, and you can actually see in the end mill there's some what appears to be soot from that accident. I JB welded some 3D printed rings after noticing there was some wobble while milling. With all the major components finished, I then put in the board, which I cut out to the correct dimensions, and drilled some M5 size holes in order to secure it. This waste board is some MDF, some spare MDF I have, and I use some double tape. Ideally you would use screws, but I don't really want to do that because I think it damages the actual board. So that pretty much sums up the build, and if you have any questions, feel free to comment below. I know I glossed over a few things. You can expect more uploads, I guess, because this will enable me to do more, and thank you for watching.